Okay, okay. So let's see, we're told that we have friction and that the friction between these two surfaces is exactly the same as the friction between these two surfaces.
Yeah.
So we want to find this in terms of, whoops, what was that sound?
Oh, that might have been my computer. My bad.
Oh, okay. Oh, I just lost what I was doing.
Oh, I'm sorry.
No, 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 no. No, it's still me getting, oh, I just stopped sharing, didn't I? Okay, that's why. Okay. So we know that this force friction is same here as it is between there, and then we have, oh my gosh, tension that way, tension that way. So if we have a force being applied that way and we have kinetic, so the one thing we don't know is whether or not we have acceleration. Oh no, there is acceleration, so it wants A.
Mm-hmm.
So that tells me either friction is accelerating this thing in reverse, which doesn't make any sense, or acceleration is in the direction of this applied force.
Mm-hmm.
Okay, so now the ugliness begins. Let's see. I am going to, yeah, let's see this. So this one I have a force normal up. We'll call that force normal 1.
Mm-hmm.
And then it also has a force of gravity down. Drawing it here because this box is going to get really ugly in a second.
Mm-hmm.
And then I have, let's see, this force of tension this way. And the same thing for this one. I know I have a force of tension that way.
Mm-hmm.
But I also have, if this thing is going this way, let's see, it's going this way, so this box is going to move this way. I already started drawing that line the wrong direction. The force of friction this thing is experiencing is going this way. It's resisting that motion.
Mm-hmm.
Whew. Let's see, is that it? So we have tension, friction opposing the motion, normal, and gravity. So let me go ahead and take that one down here, because this is one of those times that drawing it on the picture is not very helpful. It gets visually cluttered.
Yeah.
So I have, let's see, I have a force of friction this way.
Mm-hmm.
I have, and let's call this 1 because we know that I'm going to have friction down here. So I have force of friction 1 going that way. I have the force normal up, call that 1. I have the force of gravity 1 down. And then I have this force of tension pulling it that way. See, I know that my acceleration is this way. Ooh, which makes us all uncomfortable because friction is going in the same direction as acceleration, and that just seems odd.
Yeah.
But that we're going to see why that is. So now, mass 2. Ooh, mass 2. I'm not even going to try to draw it on there because I don't think we'll be able to see it well. And here's mass 2. Let's see. So I have a force applied going that way. There's my force applied. Do I have anything else going to the right for this force? I look at it and see force of friction down here is going to be resisting that motion. So this is force of friction. We'll call that 2 because this is between mass 2 and the ground.
Mm-hmm.
Let's see, and then I look up here. In this one, this force of friction is opposing its motion this way. Do you think the friction is the same that mass 1 experiences as mass 2 experiences for in between these two boxes?
No, because they have different. Are they gonna have different normal forces?
They'll have different normal forces, but in this one, this is two things. Now, you've got to be careful that you can't see my hands. So this is two things doing this, right? So there's this normal force for the contact between them that's resisting that motion. So this here, the force of friction that is slowing this mass down is going to be the exact same friction that mass 2 experiences from mass 1.
Oh, yes. Okay, got you.
Okay, so that one, I'll just do this, is force of friction, and we call that force of friction 1. Okay, and let's see. Oh, I am not done because there's a third force of tension pulling this way. Oh, yeah, I know. And then we start to cry, and then we're like, oh, wait. But we're almost done.
The third tension? Where is that coming from?
This is the applied.
Uh-huh.
This is the tension from that cable.
Yeah.
So these are the two frictions, the one between the surface, I'm sorry, between the
yeah.
boxes,
Okay.
and then between the surface.
Okay, got you.
Okay,
Oh gosh.
we're getting closer. We have, let's see, let's just go for the nice one, the force of gravity of 2. So it's force of gravity. What else do I have?
Normal force.
I have the normal force up
Oh gosh.
from 2, but I have mass 1 pushing down on mass 2. So in this case, I have the normal force for 1 is up. That means there's also a normal force coming down from mass 1.
Okay.
Yeah, no, I told you, if you can do this, you can tackle anything thrown your way.
Oh my gosh. Okay, cool.
So, but now I've been kind of careful. I have, let's do a sum of forces because I think we can simplify this relatively quickly. Sum of forces in my y. Let's see if I go up, and let's make to the right positive because that's the direction of my acceleration.
Yeah.
So in the y, let's see, I have the force normal 1 minus the force of gravity 1. What does that equal? Oops, I told you as I was writing it. Didn't give you a chance. It's not flying up in the air. It's a habit, sorry.
Exactly. It's not going to the ground. It's not flying to the air. Gotcha.
Yeah. So it's not flying up in the air and it's not plummeting down to the earth. So the sum of my y is 0.
Uh-huh.
So I can rewrite this that I know that force, and I'm going to remind myself 2 things. It's moving, so the force of friction equals the force normal times the coefficient of friction.
Yes.
And because it's an easy one to forget, the force of gravity is mass times gravity. So those are really the only 2 equations that we have. Everything else we have to make.
Mm-hmm.
So I look here, I'm like, okay, instead of all these subscripts and losing things, let's go ahead and rewrite this as the force normal 1 equals moving the force of gravity to the other side, mass 1 times gravity. Okay. And then the force of friction, let's do my x. In the x I have, the force of friction 1 to the right is positive, which makes us break out in hives, but that's okay. Minus the force of tension. And now this thing is accelerating to the right, so equals mass 1 times acceleration.
Okay. Gotcha.
Okay, so now force of friction, though, is in terms of the normal because this thing is moving. And for both surfaces, mu is the same between the 2 boxes and between here.
Mm-hmm.
So I can go mu mass 1 g minus the force of tension equals mass 1a. I'm going to stop there so I don't run out of space because I'm definitely getting ready to smush things. But I look at this and what did it tell me? It wants things not in terms of tension. So I need to get rid of that. So I know right out of the gate that I need to simplify this.
Yeah.
But now let's do our ugly sum.
I think I'm confused with the blue part. So
This
where
one?
where did you get that from?
So this is the force of friction substitution. So see, force normal is mass times gravity.
Uh-huh. And then you multiply it by mu and
Yep.
then you, okay, gotcha. Gotcha.
Yep. So I made that substitution.
Okay.
All right, here we go. Sum of forces in the, I think it's ugly no matter which way we do it. Let's just start with the x, why not? Force applied to the right. Okay, and then I have 3 things opposing that. Minus the force of tension, minus the force of friction 2, minus the force of friction 1 equals mass 2 times acceleration.
Wow.
Oof. Sum of forces in the y. Is this one uglier? It's not. It's actually a little prettier. So up is force normal 2 minus force normal 1 minus the force of gravity 2, And now I'm going to ask you, what does that equal?
That is equal to 0. 'cause you're
Awesome.
not-
Yeah, see, this time I didn't write it as I asked the question.
Nice.
Cool. So, but I feel like we know some of these things. We know that the force normal 1 is mass 1 times gravity. So what I like to do is go ahead and simplify this now. I have force normal 2. And I'm going to move these two to the other side because I know I need this for the force of friction.
Mhm.
Equals force normal 1 is mass 1 times gravity plus the force of gravity 2, which is mass 2 times gravity.
Okay. Yeah.
So in retrospect, this should make sense because my force of friction then is going to be both of these masses pushing down on the ground, and that's the contact force between mass 2 and the ground.
Mhm.
So if I want, we're going to need 2 pages. Oh dear. All right. So from here, I can go, let's see, remind myself, force of friction equals force normal times mu. Mu is the same for both. So the force of friction 2, how do we label these? I labeled this friction 1, so yeah, force of friction 2 equals the force normal, M1, yeah. I was trying to think if I wanted to simplify that, mass 2 G times mu.
Okay. Got you.
Whew. So let's see, I have force of friction 2. I have force of friction 1. I have applied force. I have mass 2 times acceleration. I am so close to done.
Mhm.
And then we can throw a party. Let's see. So it wants everything in terms of that. So let's go ahead over here and simplify that the force of tension, because I need that thing to go away. Moving it to the right-hand side and subtracting mass 1 acceleration on the left. I
Mhm.
get force of tension equals mu m1g minus m1a. So let's see if that makes sense. So force of tension, I'm accelerating this way,
Mhm.
going that away. Whoops, you can't see. Accelerating that away. And let's see, what do I have opposing that is the force of friction. Oof, yeah. So the force of tension, if this box is moving this way, oh, what mistake did I make?
Ooh,
Oh, no, we're good.
okay.
No, we're not. I made a mistake.
Okay. Is it because it's the did you I don't see
I
it.
went generic like, right? This box is accelerating that way. The magnitude of the accelerations will be the same, but
Mhm.
this box is accelerating this way. So this would be acceleration 2 and acceleration 1.
Yeah, because I was gonna say, I was like, I feel like the other one is going
Yep.
the other direction.
Yep, yep, yep.
Okay,
So
got
let's
you.
go ahead and fix that.
Oh gosh. Okay.
And that's why when starting to talk that through, I'm like, that doesn't make any sense,
Mhm.
right? Because the acceleration, the tension is accelerating it this way, and it's having to overcome the force of friction. So that's where I looked at this sign. I'm like, no, that's not logical. There's got to be an error there. There we go. Anybody have questions on what we've done so far? Are we good?
I think I'm good.
Okay. So I've defined tension. So I can put that into this. Force applied, that's okay. We can leave that. I've defined friction for 2 and for 1.
Mhm.
Let's remind ourselves what force of friction 1 is, just so it's easier. That force normal 1 is that, so force of friction 1 is mu mass 1 times gravity. Okay, so now we want to make our substitution. So I have this force applied minus the force of tension minus the force of friction 2 minus the force of friction 1 equals mass 2 times acceleration.
Mhm.
So force applied. minus, making this substitution, mu m1g plus mu, m1a. So that's my tension. Minus the force of friction 2 is that one. So minus, let's just go ahead and distribute that mu, m1g plus mu m2g. There's that friction part for 2, and then the friction part for 1 is just the mu m1g equals m2a. Whoa. Let's see. What can we do here? We can find, oh, we need to solve for this. Ooh. Okay, so that's not so bad. Because all we're going to do is move these things over to that side. Because it just wants it in terms of this applied force. So force applied equals mu m1g plus m1a. And this whole thing is added to the other side. So plus mu m1g plus mu m2g plus mu m1g.
Okay.
Now I feel like I can make this kind of prettier. Let's see, I have 1 mu m1g, so equals 2 mu m1g's. And what I like to do when I'm simplifying things like that is just do a line through them so I can keep track. Oh, I forgot my acceleration. I'm like, I'm missing an acceleration.
Are we solving for acceleration? Wait.
No, acceleration was over here. I moved everything over and then just forgot to include it.
Okay.
It wants everything in terms of the force applied.
Okay, cool.
So we're just now bringing everything together. Let's see, and then I have mu m1g, mu m2g. Do I have 3?
I think you have 3.
I do.
M1Gs.
Yep.
Yeah.
Plus mu m2g. There's that piece. Plus acceleration times mass 1 plus mass 2. That's just those two pieces. I feel like I can simplify this a little bit more. So I can go mu g times 3 mass 1. So 3 mass 1, mu g is out. Mu g is out, plus mass 2, plus acceleration times mass 1 plus mass 2. And all of that is my applied force. Done.
Okay.
Cool.
All right. I think I might have to like stare at that for a while.
Did you hear my advice on how to do?
Yeah. Can I potentially get the first one?
First page.
And I can do the screenshotting thing. And then here, actually, I can do this one first.
Oh, here it goes.
Or
No, that's not it. That's it. There you go.
Sweet. Here, I'll just do the little screenshot.